Hello everyone, I am Uttam Satpute, Professor Electrical Engineering Department at D.Y. Patil Pratishthan's College of Engineering, Sanagar. In this video, we will see the unit commitment and the constraints. So, in the question bank, they ask the question, explain unit commitment and the different constraints. So, now what is unit commitment? Let us first understand what is unit commitment. The difference between economical load scheduling and unit commitment is that unit commitment is similar to economical load scheduling, but it is within a plant. It is not for the power system. So suppose if I have a plant, suppose say I take a plant, say Koina plant, and I have uh, let us take Chandrapur plant because we are considering thermal power plants, not hydro. So let us take Chandrapur power plant, which is thermal. And now we have, this generator. Suppose I have unit 1, 2, 3, and so on. Now, from economical load scheduling, we get what should be the generation from this. Suppose I from after running economical load dispatch, suppose I come to a conclusion that this plant should give 1000 megawatt. Now from this 1000 megawatt, the next question is how much I should generate from this unit, how much I should generate from second unit, how much I should generate from third unit. Now finding this allocation or scheduling, this is called as unit commitment. So what you can write, the the objective of unit commitment, you can write what is the objective of unit commitment. I'm writing in short, please. The objective of unit commitment is to commit the units or to allocate, you can say allocate the generation, allocate the generation from the units in a plant, units in a plant for the given, for the given, for the given generation, for the given generation, and the generation it is from economical load scheduling. Okay, so this is the objective of unit commitment. The objective of unit commitment is to allocate the generation from units in a plant for the given generation. Okay, now there are different methods for solving this unit commitment problem. The methods of solving UT problem, that is unit commitment problem. Please change this UC, unit commitment problem. Uh, One is called as priority test. Priority test. Now these methods we are not going in detail. but dynamic programming, dynamic programming. Then we have Lagrangian multiplier method, multiplier method. Okay. Uh, we do not have these methods to study in detail. Okay, but we have to understand the constraints. So uh, we will discuss now the constraints that are considered during unit commitment problem. Following are the different method. Following are the constraints. Constraint means what? When you allocate a generation to a unit, we have to meet certain conditions. That is what we call it as constraint. Following are constraints to unit commitment problem. The first one is spinning reserve. So what is spinning reserve? Spinning reserve means in a plant some units are reserved for generation. So you cannot allocate any generation as you want. That because of certain conditions, some plants, some units, you can say some units in a plant are reserved. Reserved for ensuring, say, a reliable operation, for ensuring uh, a reliable operation. So this impose constraint on unit commitment. So this impose constraint on unit commitment. Okay. The second one is thermal constraints. Thermal constraint because we are dealing with a thermal power plant, and because the boiler it is there for is required for generating the steam to run the turbines, and that boiler puts so many constraints. So the thermal constraints, they are something like minimum uptime. Minimum uptime means what? Some units, after they are started, you cannot suddenly shut down. You have to keep it on for certain time. Once the unit is committed, once the unit is it is to be it is to be on for some minimum time. It is to be on for some minimum time. You cannot shut down immediately minimum time. So this impose a constraint. Second one is minimum downtime. Minimum downtime means once the unit is down, when once you shut down the unit, you cannot start the unit. There is certain time it has to be kept down. So that puts the condition. So once the unit is down, once the unit is down, down means stop. You can say down. It is to be it is to be kept off for it is to be kept off for certain minimum time. So for certain minimum time. So this put a constraint. Then there is another what we call it as crew constraint. Crew constraint. Crew means uh, the skilled labors. Crew constraints. Crew means skilled labor means skilled person, skilled uh, person required to required to start and stop the unit, to start or stop the unit. And this also puts some constraint on the unit commitment problem. Then the third one is startup constraint. Startup constraint means what? The thermal generator do not start or stop immediately. Right? The thermal plants or thermal unit, the thermal generators, we can say the thermal generators do not start or do not start or stop immediately. Why? Because of boiler. So to generate a steam of super uh, a very high temperature and pressure, we have to keep it. We require certain time. So that put constraint on the thermal unit. The thermal generator do not start immediately. So it imposes constraint on unit commitment. And the fourth one is must run. Means what? Must run. Some units in the plant, they are given the status of must run. Some units in a plant are given must run condition. Given status of must run means they should be on. Whatever is the whatever you do with other units, that is not a problem. But some units they are given must run condition. Then the fuel constraint. The last one is fuel constraint. Fuel constraint means what? Now in thermal plant, in thermal plant, the input is coal. Okay, the input is coal, and uh, the price of this, the price of coal, the price of coal and availability is volatile. Availability is volatile. So this also put constraint. So this also put constraint on the unit commitment problem. So these are the various constraints that are considered while doing the unit commitment problem. So in this in this video up to this only. Thank you very much.